Hey everybody, welcome to the stream. Hope you're having a good day. It's a little bit rainy here today. Um, and sorry, I just got really distracted because I started I'm grinning because I started a thread in the Gleam Discord server or a discussion. And yeah, I mean, in typical Gleam Discord server fashion, it's full of silliness. So that's good. Anyway, today, so what I want to do today is get to the point where we can do sequences of curves. So, I originally titled this library that we've been working on Splines, um, and it is for that purpose. So even though what I've been calling things splines, they're actually just parametric curves. There's nothing saying you have to keep the range of your input between 0 and 1. That's just the convention that says, hey, you have these knots defining this curve, and the section where it's, I don't know, well defined or expected or has particularly well known behavior is between 0 and 1. But usually what happens, especially if you're like using a Bezier spline to draw shapes or boundaries between things, you have what is technically a sequence of curves. And those curves are, each one has like you interpolate 0 to 1 across that curve. So you have a sequence of 0 to 1, 0 to 1, 0 to 1, 0 to 1 for as many segments, as many different curves as you want. And those curves share knots, they share points. Usually at the endpoints, but it's also possible, for instance, if you wanted to make a Bezier spline that has some sense of continuity across an endpoint of one segment. Usually what you do is you take the control point that came before the endpoint and reflect it across, and that becomes your next control point. So that's very typical in editing software. Like you drag one control point and the other one on the opposite side of that one moves in a mirror fashion. So there are lots of different options on what we can do. The first thing I want to do, because I think it will work really well for the Catmull ROM, is let's just do sequences of 4 points. The Catmull ROM, if you watched the Freya's video, which I keep plugging, please go watch it. It is so good. Freya talks about how the Catmull ROM is basically you're ensured that the curve goes through all points except the last one and the first one. So you can think of each segment as a 4 points, and then you move it by 1, and that's a new segment, right? So that the second point in the first curve becomes the outer control point on the second curve, and so forth. So just to let's get this going, because I want to make sure that I'm demonstrating what. Except I messed things up. We're going to fix some things. All right, first of all, we're going to get back over to this screen. Okay, we're going to Gleam. Okay, and now it's going to go build everything again, which is fine. And I messed things up. What is it? Do I have... No, it just uses splines from the parent directory. And here I've got this is my, it was called MATX, but all right, just to remove the build artifacts, and let's try one more time. I probably got something else wrong. Okay, so it cannot find MATX. So here, I'm not using that name anywhere. I'm not using it here. All right, let's try Gleam clean here in the root directory of our splines. Yeah, okay, so there's something else wrong. There's something, let's just find MATX, find that where that is. Okay, so I need to clean that out of the manifest toml. Let's just delete that and see what happens. Okay, so, and this needs to be matrix Gleam. Okay, we'll fix that. Try Gleam build now. Where? I saved everything here. Let's see where it still exists. Oh, okay. So splines, this is matrix Gleam. I really wish I didn't have to do this. Okay, let's try one more time. Sure, okay. That's fine. It actually got the thing built correctly now. So over here, let's just run clean just to be sure. Yeah, okay. And then we'll run Luster. I wanted to get to the, I didn't realize this was going to be broken because I renamed that package. But it was a mess. Okay, so I have a problem here. Why did that work? Okay. Let's run clean again one more time. And build. Okay, so what's going on here? It says b.gleam. It doesn't find mat4f, which, not vec. But here's mat4f. I don't know what's wrong there. Okay, so we should see down in here, like, you know, we get mat4f as not essentials of compilations. Sorry, I've been upgrading my operating system, and so it kind of broke some things. The fact that this built okay. I imported mat4f. Matrix mat4f. Let's do a clean one more time. The other thing I could do here that might make is just rebuild the manifest. Depths download. Okay. 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 I, honestly, I shouldn't have to do that, but I messed with so many things with renaming that I could understand why it was just broken. All right, here we go. Live stream. Okay, so Catmull ROM. Remember, this is. I did not put text on here. I do want at some point to like draw some debug text on here. It's saying which curve this is. But you know, this is a Bezier. This is a B spline. This is a Catmull ROM, and the Catmull ROM is guaranteed to go through knots by design, and except that the first and the last one, right? So this is the first point. This is the last point. So if we say added another point up here, which we'll do in a moment, and then that becomes this is the first point and this other point is the last point, and you get a curve between these two. So for Catmull ROM specifically, we can take overlapping sequences of 4 points. All right, so let's look at Bezier. Bezier has, you know, on each segment has an endpoint, or a start point and an end point, and 2 control points for a cubic. We're only considering cubic here. So this means that if we want another curve, we have to take them as this is the end point, or this is the start point of the new curve, and you have 3 more points. So these are only overlapping on so rather than like sliding windows, you have a sliding window but you skip 3, right? So this becomes the first point, and then you have another control point and an end point. So you know, let's figure that out. For B splines, I'm less aware, and we're gonna have to look into what's appropriate there. You can see here though that with the B spline, it's not guaranteed to go through any points. In fact, it's likely not to go through them. But I suspect that it also is like Catmull ROM in that you you add another point and you start from here as the control point, or as the first knot, and so forth. We're gonna have to look into that. Okay. So I want to do some stuff here. Let's yes. Lots. We need to restart the language server. Okay. So here we've chosen to do cubic because there's 4 knots, 4 points. If we do, let's go here. What I want to get to is a version where we can pass 4 points to the constructor and then like build up those sequences. So maybe what we'll do is first of all, I'm going to add that we have B splines. Okay. And we'll move this up. Okay. So maybe what we'll do is we'll say we'll have a constructor here, and maybe what it does is we can coalesce the behavior of, you know, how you construct one of these things. And just like have these be the quick way. So let's maybe make an example. And this is, you know, you can still use these inner ones, but I think that where the curve passes through all but the first and last points in the sequence. The list of points must have at least 4. Must be length 4. Okay, so this is going to be, and I could say points or knots. I'm going to use points because that's what I've been saying, even though they're really knots. K-N-O-T-S. And this is going to be a list of back to F, right? And what we're going to do here is we're going to have a result. And I think what we want is let's make a type here. And we're just going to call it spline. And I kind of want to make it opaque. Maybe we don't need to. Let's leave it open for now. And we're going to say spline is going to be, it's going to have a contain curves, and it's going to be a list of A. And then it's going to have a sample function, which takes an A and a float and returns the problem here is I don't know how we relate. You know, we don't have higher kinded types here. What I want to say is that A and P are related, but I can't guarantee that. Because what I want to do is say a sample, which takes a spline, which is a spline of A and P, and you know, T is a float, and this is going to return a P. And the idea here is we want to and it maybe would make sense to just write the documentation for this first. Samples a generic spline at time t. And let's say, I want to say this is, we may want to just say, let's say this constructor is uniform spline. And we will maybe make the possibility of non-uniform splines later. And a non-uniform spline would be like telling us where the split points are on the curve. So the real popular one there is NURBS, non-uniform rational B-splines. I don't recall what the rational part means, but for now we're only concerned with the uniform splines. So what we want to do is we want to find an integer part of t, right? So let's go back here to the standard lib, and I think that there should be a function. Truncate gives you an int. Okay, so we're going to say index is int.truncate. Import Gleam int, except it's float. Derp. Truncate t. So what we want to do next is get the we want to get the one that is at a particular index in the list. So the problem is if t goes beyond the length of the curves, then, and it's probably worth doing just a case spline here, even though there's only one case, because this is only going to be relevant for uniform splines. For other kinds of splines, non-uniform, like we're going to have a different algorithm for figuring out which curve to sample, right? Okay, so what we want I feel like I want to do index fold. Or index map. There's no nth function in here. Now we could do take. So like if we take 0, or rather drop is what we want. So let's say curves we want to take that. So that would, for 0, or not take, we want to drop. For 0, we'd still be left with the original list, and we'd get the first one. For 1, for anything okay, so if we have a curve then that's the one we sample. But we have to subtract the index from it. If we end up with an empty list, then we need to pick the last one. And I think that it's worth saying we should panic if that is the case. So here we're going to say, well, the result is sample curve with t minus we got float. We have int to float. Int to float. Index. What's wrong there? Okay, we need to import Gleam int. Okay, and now, yeah, it's just complaining about that's never used. I just don't care about it, so leave it off. Okay, so the idea here is, let's say t is between 0 and 1, right? So that means we want to sample the first curve in the sequence, in the spline. And so this index will be 0 because it's less than 1. We've truncated all the digits off and left just the integer part. So then what that means is we want the first curve. So we drop 0 from the list. And that leaves us with the 1 curve. Now, this is the hard one. So I'm going to move it down. And this pattern will work even if there is only 1 left. So if let's say there's 2 curves in this spline, and we want an index 1. And so this is 1. We drop 1, which means there's only 1 left, and this dot dot can just be the empty list. That's fine. The problem is when you say, well, I want to sample it at 2.5 and there's only 2 curves. When I say I want to drop 2, well, now you have an empty list. So what we need to do is go back and say, we need to look at a list last. The other problem is, what if t is less than 0? So maybe we need to think about this a little bit differently. So let's say case index when if neg less than 0. Then what we want to do is sample the first one. Okay, so this will be let's comment this out for now. So if it's less than 0, then we want to curve So if it's less than 0, then the first curve dominates, right? Okay, so if it's greater than the length of the list, let's see. let's say there's 5. So 0, let's say if it's greater than or equal to the length of the list. Yeah, it can't be used, even though that's guard safe. Okay, so let's say let length curves. So then what we want to do is we know we want to sample the last curve. So what we're going to do here is we're going to sample t minus int to float. And what we're going to pass here is length minus 1. Okay? Okay, so then if it's anything else, this is where we're actually inside the curve. So this is, here in this case we are before the beginning of the curve. Now the other thing that we could do is clamp, but I think that that's probably less intuitive than, well, if you go beyond, you're going to get results that don't necessarily conform. They will be based on the first or the last segment. After the, and this is not the curve, the spline, after the end of the spline. Okay. So if it's anything else, then we do this. And we're going to do and we don't need let assert. Okay, it's just curve. And I think it's fine to panic here because we've already checked our boundary conditions. So we're going to say list.drop curves index. This is basically what we were doing before. And then we're going to sample curve t minus int to float index. Okay, so I think what I want to do is let's go ahead and get this catmull rom. So what we're going to do here is this is going to return a result of a spline of, we need to import this. This is basically the type we want. Catmull rom vec2f, and vec2f is the point type. So, and we're going to import splines, catmull rom, type catmull rom. Okay. All right, so this is a to-do for now. Okay, so what we're going to do is I want to say use and this needs a nil type. We want to make sure that the length is at least 4. So I think it's bool.guard. See how that works. Run a callback function if the given bool is false, otherwise return a default value. Okay, so we're gonna do bool guard. It's interesting that it's false. Requirement is false. But I guess it's when this thing happens, return that. So is there an easier way? Guess not. Okay, so when list.length points less than 4, return nil. Okay, so this is, we wanted to return error nil, right? Hey, I'm sorry I didn't announce it in the channel. I got distracted on asking in general. How do we create a channel for whatever purpose? And they're like, we don't create channels. Anyway, you know, the other possibility is that result has a guard type thing. Huh. It does not. It's okay. The other way we can do this is not flattened, and I think that that will make more sense. So we're going to say list.length points less than 4. And in that case, if that's true, then we're going to return error nil. Yeah, it would be cool. Okay, so if it is at least, if there are at least 4 points, then what we want to do is take those points and we want to iterate over them in like that windowed fashion. So this is sliding windows, which is what we want for CatMoRom. So let's do list.windows, windows of 4, okay? And then we're going to take we're going to map over that, right? And the thing is, it's not. We're going to have a. So this is one window, right? We need to do this. Even though we know that it's going to be that, we need to use that let assert there. Okay, and then we're going to say CatMoRom new 2D P0, P1, P2, P3. Okay, this is going to be let curves is that. So now we can say let's make a uniform spline that has curves, and sample is CatMoRom.sample. Except we need to wrap that in OK, and then it'll be fine. All right, so that feels pretty good. I think a mod will have to be noted and want to open a channel. Yeah, I agree. And I mean, like, a mod replied to me right away. So, you know, and they were saying we don't really make channels. Haley said, ask really nicely and then get told, nah, maybe in the future. I'm like, okay. Okay, so this is a full, like, multi-segment spline for Catmull ROM. So let's go and use it now. And we don't need Gleam Bool in here. T gets applied to the contained curve. Definitions depends on whether the spline is uniform or not. Okay. For non-uniform, I think that the answer is going to be pretty simple. It's going to be, we have the same format as this, but then you have a set of segments. So like we would, I'm going to comment this out. I'm going to say non-uniform spline. And this is going to be, or we'll have knots. And this is going to be a list of float. And then curves, list of A. And sample, which is a function of A float to P. But I'm going to comment this out because I don't know how to do this yet, and I don't know that it's even correct. But this is my intuition about how it will be constructed. The other option is that what we do is, rather than this being a list of A, this is a list of tuples of float in A. And that's probably what we do. Yeah, so this might be like float in A, where this is the minimum. Yeah, this is the minimum value for T for that curve. So that's a possibility, either one of those. I think that the non-uniform one will be really valuable if the goal is something like you want to have an object move with a continuous velocity on a particular path. I say continuous velocity, that's not correct. Continuous speed on a particular path. Which will mean the acceleration will be all over the place on turns. But then you could say, hey, you know, this segment of the curve takes longer because it is a greater distance, and that's what lets you that's what would this, you know, non-uniform form would let you do that. There's even a possibility, I guess, if we did derivatives. Or would that be integration? We could do some symbolic calculus basically, and figure out what is the length of a particular segment, and use that to scale time. So, yeah. But the other thing is that it would not, you know, because it's non-uniform, we would need to know, it would be like, you know, not only do we need to subtract this minimum from T, but we'd also look at what's the distance, or what's the factor in the next curve, and use that to scale T down so that we get 0 to 1 along the same thing. So that'll be really interesting. I don't know what we'll do yet there. Okay, so what I want to do is let's go back to our example, and rather than this, let's add some more points. So I want to look at our showcase here. So this is the Bezier, this is the B-spline, this is the Catmull ROM. Rather than doing this, I want to make it, let's import splines. And we're going to say this is points. We'll start with that. And then we know that there's only going to be one segment here. So I think that what we want to do is do spline sample. Oh, wait. So this is going to be, we need to let assert okay here. I was like, why is that not working? So for now, let's go back and look at our thing. Refresh. Okay, so it still works. It's just now we've got we can add more points to it. So let's see. So we've got this, 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 and this, and let's make one that's kind of out here in the upper left quadrant. So we're going to need negative y and positive x. So we're going to need positive x, oh no, negative x and positive y. So let's do negative 100 and positive 150. Okay, so now we've got this other control point, but we're not interpolating this. So we need to go and I think we need to get a way to do this more generically. Let's see if there's something in the list module that will help us. There's list range. Use int range, okay. So I think that what I want to do is say let's define max t here, and that's going to be list.length points minus 4, right? So no, minus 3. Okay, so we're going to say int range zero. Let's see, what are the arguments to this? From 0 to max t, right? With, and the accumulator, we'll just have a list. And it actually doesn't matter which Yeah. It actually doesn't matter which direction we go, but I'll probably want to reverse it for sanity's sake. Okay, so, and then the reducer is going to be, that takes the accumulator L and I want to do times 10 here, and you'll understand why in a second, because we're going to divide by 10. So this, if we have only 4 points, that'll give us 0 to 1, except it'll be 0 to 10, and then we can divide by 10 to get, you know, some level of granularity on the segments. Nope. 10. Just 10, please. You don't need to autofill that. Segments. Okay. So then we have a list and we have an integer. And what we want to do is we want to put on the front okay. So then we're going to, that's going to return a list, right? List of float. Let's reverse it. What's wrong here? Oh, it's run. Okay. So, yeah, that'll give us... That should give us more. So let's go back to our showcase, and hey, we've got more segments. Now this is exclusive, so it didn't go through the point, so we need to add one. What's wrong? Oh yeah, not parentheses, brackets. You can switch from and to, so you don't need +1. That would also build it in reverse, wouldn't it? Okay, so that's kind of interesting. No, we picked this point way out here, but it's still going through that new control point. I want to put that a little bit closer, so let's put it at 0, 0. Let's actually just add a new one up here and do 0, 0. And then we've got, you know, additional points. Oh, I see. Yeah, that's actually not a bad idea. Let's switch that up. That'll make it quite a bit cleaner. So let's do, this is from to -1. And then we don't need the list reverse. Okay, still works. Thank you, NMB. Good one. Good idea. So now, you know, I can keep adding points to this. Let's make one that's like... At some point I'll implement picking in this showcase, and you can just like add points and draw the curve. It wouldn't be picking exactly, it'd be more like, you know, mouse input, where is it on the canvas sort of thing. Picking is actually when you select something, and that would also be valuable. But we haven't built this such that it's going to be easy to edit an existing curve. It's more like we're just going to recreate it on every redraw. So we could keep adding them, and you know, see they keep going through the points. You learned this tip from Jack. Oh, that's great. Jack is awesome. And Giacomo. Okay, I think that's pretty sweet. You know, here's our Catmull ROM with, you know, the start and end points are all over the place. But we've got some interesting curve, and you know, it's got some nice continuity properties, and it goes through all the points except for the penultimate ones. Now, some implementations of Catmull ROM will say you don't specify the start or the outer control points. You mirror the ones that are inner. So like you would do, you know, mirror this across this point, and that would be the control point, and the same on the end. But we haven't implemented it that way. So that is an option. But I don't really want to do that right now. So I just wanted to get multi-segment splines working first. I think that's pretty cool. Nanaba. Okay. I've just been saying NNB. Nanaba. That is easier. Thank you. And my apologies for being unable to pronounce your name properly. Okay. Okay, so we could do, we can replicate this for 3D. And honestly, it's just neat. Because of the way that we constructed this. Vec3F. 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 Unfortunately, because of the way these are why don't I just import that type? Duh. By the way, I do, maybe we'll spend the second half of my stream today. I do have updates for the PR I sent you, Nanaba. And we'll get to that. Maybe we'll finish that up today. Okay, cool. This is getting better. Now let's do Beziers, because I think Beziers are also fairly straightforward. But like I talked about earlier in the stream, the way that you pick the number of points, or I'm sorry, the way that you pick points is different than Catmull ROM. Catmull ROM is you always have these 2 points at the ends that are not on the curve, and then all the points in the middle are on the curve. Whereas with Beziers, the points in the middle are not on the curve. It's the 2 endpoints in like groups of 4. So I think that I want to make the assumption that you will not be mirroring points automatically. And then you just you have to give a minimum of 4 points, but you could give 7 points. You could give you could give 10 points and so forth. So yeah, we need to figure out that computation. And the thing is, it's going to look very similar to this, right? So we're going to say this constructs a sequence of Bezier. We're going to say cubic Bezier. And we'll do 3D first, where the curve passes through every third point. When we phrase it as where where every segment has 2 control points. Now, it's possible to define a spline where the endpoints don't match. There's nothing technically wrong with that, but it's about how you construct it. So you could say, just take, I'll do the duplication myself. Just take 4 points. Every 4 points is a new Bezier curve. But they would not be C0 continuous, right? They would be discontinuous. This is a really awkward way to phrase this. First 4. So this comes down to whether we whether we have the correct number of points. Okay. Okay, so we need to redo this, and also our condition here. And honestly, I'm just going to put an or in here. This is going to get ugly. But basically, we want to see that for that's not what I wanted. I wanted this. So we want to get the remainder. Percent operator, honestly. Okay, I'm going to make this clause to do, and then it's going to stop complaining about that. The main thing here is we're saying the number of points. Okay, and this is negated, so if the number of points is less than 4, or the number of points minus 4 mod 3 is not 0. So if it's 4, that'll be 0, mod 3 is 0. If it's 5, mod 3 will be 1, it's not 0, and so forth. If it's 7, that'll be minus 4 is 3, 3 mod 3 is 0, right? Okay, so that's what we're trying to determine. Okay, so now let's look at the Bezier constructor. And I kind of want to, you know, we did this as like this form. Yeah, so let's figure out how we can construct that from the points that we have. Okay, so we have the list of points. And we're going to do a similar thing to what we did for Catmull ROM. So we're going to do windows of 4. But we want to skip 2 in the middle. So we want to repeatedly skip. We want to do windows of windows. Is that crazy? The problem is it don't want combinations. Not group. It's sort of like index fold. Yeah. Let's do index fold. Okay, so index fold, and we'll take the initial as a list. not fold, no. Yeah, I think we want index fold. That will let us do our. So here we have the accumulator, and we're going to get the. The index fold gives you. Oh, it actually has it's a ternary function, not a binary function. Okay, so this is the window, and this is the index. If we say index mod 3, if it's 0, then we want to do if it's anything else, then we want accumulator. So it's basically saying for zero, like for the 0th window, we'll take it. For the the third one, which would be the 4th point, right? We'll take it. And then we skip 4 and 5, and then 6 we take it because that's the 7th point, and that fits our that fits what we want to do here. So we want to do Bezier new 3D of the window. And then what we're going to return is OK, uniform spline, curves, and sample is Bezier.sample. Okay, do you all follow that? I hope so. Like, you know, all of this stuff is, sometimes I feel like it's, you know, leet code interview material. Like, how do you get the, you know, sequences of 4 points from a list where, you know, the 4, like it's, you know, like overlapping segments with only the first and the last. Like, this is the sort of thing you do in those sorts of things. But this is very, like, fundamental type of algorithm. And I'm going to make the 2D version now, and it's going to be really simple. Back 2F, back 2F, back 2F, and the new 2D. And just for sake of consistency, let's move this above. And let's move all of these, all the Beziers, above the Catmull ROMs so that we're kind of in alphabetical order. Okay, so now let's look at our Catmull ROM example here, and we have 1, 2, 3, 4, 5, 6, 7. So this is the same number of points. We could do a Bezier 2D and have multiple segments. I love a well-organized life. Hi, Amos. How are you doing? Okay, so we're going to change this Splines, Bezier 3D. And we need to let assert OK here. Bezier 2D. There we go. And then down here we're going to do spline.sample. Okay, now we need to do, so this is still going to sample only from 0 to 1, which is still only going to give us the first curve, right? So we need to figure out what the max t here is. And it's really, trying to stay dry and warm, same segments. We'll do the same thing as we did in Catmull ROM. Yeah, so we're going to do something like this, except it's not. How do we know the number? This is going to be right? Why do I say that? Because you have a starting point and 2 control points, and then you have the starting point and 2 control points, and then finally you have an end point. So either you chop off the start point or the end point, and then you consider how many segments of point on the curve and control points you have. So that gives us this. Okay, now we can use the same thing we did over here. For our segment generation. Trying to straight arm. Yeah, I'm glad you're here, Amos. Thanks for joining. Okay, so let's go back to our example. Oops. So here's our Catmull ROM. I just want to refresh, make sure we're looking good. And we use the same points for the Béziers. And we messed up. You'll note that the first segment looks correct. The second segment jumps. Why does it jump there? So these would be the 2 control points, and this should be the end point. I don't know why it's connecting to the end. I think we have some computation problem here. So let's, for argument's sake, first of all, let's rename it Bézier. Let me rename it again, Bézier Spline, just so we don't confuse it with the module name. Yeah, we've got a problem here, and maybe it's how we're doing the iteration. But you'll see that what's interesting there is you get a cusp, right? This control point does not mirror across the endpoint. So you get like a hard corner there. Oh, wild. That's not what I was expecting. Okay, so what I want to do here is go... What do I want to echo? Max, we're gonna echo Bézier spline. This is awful, and I'm sorry. Max T and num segments, and it's gonna spam the console, but I want to see what's going on. Okay, and let's pull up the console, and let's nope. That's not what I wanted. Let's pop it on the right side there, since we don't use the whole window. Okay. All right, and we're gonna switch off so we can see. And it's alighting a bunch. But our max T is 2, which is what we expect, right? And 20 segments. So, nope. I did not get that right. I'm very sorry. Messed up my window. I wanted to just make it fit the bottom center half, but I'm gonna have to drag that manually. I'm a pleb who uses rectangle for window management, so here, go away. Not using agent panel. Okay, so looking at our points, oh, you know what we didn't do? We didn't reverse. Not that that matters that much. You can see here that these are the first. It matters if we were using that for like an animation or something. But you see that that's flipped, so we need to fix that. let's fix that. And we can just do list reverse here at the end. And it's because we are using this index fold. And let's put that as well down here. Not capital ROM 2D, Bezier 2D. Okay. There we go. Now, I don't know why it's getting dash lines. I think it has to do with how we're generating that, and we like hard-coded 10 somewhere. So let's look in there. Did we hard? Oh, is it we're chop? Okay, so these are colliding. Let's just say precision 5. That should be good enough. Okay. Now they're continuous, and we have more. You can see we're spewing at the console again, but we have more precision, and it looks smoother. All right, let's get rid of that echo, and we can go back to 10. It was really just about naming those debug lines. Now you can see when we have only resolution of 10, you can see more chunkiness. So let's make it 20, smoother. And that's something that we could maybe make as a widget that you can adjust. But given this is just a showcase, we're just trying to show that our math is correct, right? So I like rectangle as well, Amos. You know, for most of my day-to-day stuff, it's really good. There are a few things where I'm like, I would like to take an irregular quarter of the screen. This is one of those cases. I have one on my work computer that that gives me top center and bottom center 1/6. Since I have this ultra wide screen, you know, a 1/6 is usually a good size for most stuff. But since I'm streaming today, I'm streaming in 1080p, but it's not exactly because this screen is actually 1440p in the center section. It's like two 1440p's, and so this is just a little random point about my streaming setup. Over on the, when you see me look over here, I'm looking at the chat that's on my OBS window. I look over here, I'm either looking at something that I pulled up for myself, or it's the Gleam Discord. So there that is. All right, so we don't need that in there anymore. I want to get to a point today where this is good to go. And maybe what we'll do is we'll go and we'll make the we'll put a pin in the matrix library and publish that to hex, so that I'm not referring to this as a path. Now, what I could do, even though I'm like actively editing this on my local machine, is I could say this is a GitHub dependency, and we could just go with that. But all right, so let's do the same treatment for the B spline. And here's the thing: is I don't know. Let's look at our sample here. So that's Bezier. This is the B spline. If we put the same points in there, I don't know. I don't know if it's like the Catmull ROM, where it's you add another point, you get another segment, or not. We could do some research on that, hopefully quickly. So you can tell I was trying to figure out how to do the inverse of 3x3 and 4x4 matrices yesterday. Okay. go to our trusty Wikipedia. And let's talk about splines. Yeah, that's what I meant. Okay, or basis spline. Spline function is I have minimal support for overlap for given degree smoothness and a set of breakpoints, knots that are partitioned in this domain. Okay. Spline curve drawn is a weighted sum of B-splines with control points, control polygon. Okay, so this is interesting. I don't know that this answers the question, but you can see here that it looks like 3 points to define one segment. 1, 2, 3, and it's 4 for, okay, so it's 4 for this middle one. If you're looking at the influence, it's possible that those are not all cubic, actually. Right. Okay, cubic B-splines. So they take 4 points. The question is if you want them to be continuous, how does this window move? Does it move by just 1? Does it move by 3? Like Bézier's do? Oh wow, there's a lot of stuff here. NURBS. Non-uniform rational B-splines in homogeneous coordinates. Their order and a knot vector and a set of control points, but unlike simple B-splines, the control points each have a weight. Okay, so yeah, that's, yeah, non-uniform. I think what I want to do is let's I don't know what that footnote is about. Is it about NURBS? Or is that footnote 3? I don't know. I don't see it. Okay, I think my gut feeling is that it's like Catmull-Rom in that we'll do the same overlapping windows of 4. I don't know that that's correct, and I think that what will happen is when we plot it, we'll find out if it's correct. So let's just duplicate this. Oh, and I need to do, oops, I messed up the wrong one. Okay, and actually we want to move these up to the top because B comes before. And I'm going to use the term that they use here. This is a basis 2D. Okay. And this is going to be vec2f's, and this is going to be B spline. Okay, so let's import splines B spline. And you know, I could rename this to basis. That might be nicer. Okay, so it should be actually telling me that I got this wrong, but there's probably something else wrong in this file. Basis 2D. Oh, and this is going to be basis 3D. Oh, well, it helps if I don't have that extra mess in there. Okay, now it's telling me the problems, the actual problems. Okay, so we're going to do B, new TD here. And this is going to be b.sample. And that's pretty easy. We could define this as a combinator. I'm not really feeling the need to right now. Cubic. All right, so now that we've got that, let's check out. Yeah, we've got 20 minutes left approximately. Let's check this out, and let's get the same set of points. And let's go ahead and rename this. Basis spline. And we're going to do the same transformation we did here. We're going to say splines dot basis 2D, and we'll pass points. And we need to let assert OK here. Okay, and now we're going to have to do the same sort of thing that we did in the other file. So let's reuse the catmull-rom one, since that's the same, it's got the same constraints, at least in our current formulation. So we're going to do that, and then we're going to do that as our generator. Okay, and let's see. Okay, it's fine. Let's see what it looks like. See if we're even correct. Okay, so catmull-rom, Bezier, basis. You know, the thing is, I can actually see that that might be still correct. There's no requirement that the basis spline go through points that are, you know, participating. But if you look at it in terms of what is the, I wish I had, you know, Freya's like awesome way of plotting this. I would love to see what the influence of each point is along the curve. But you can imagine that, you know, thinking of these like forces on the curve, this is making this section really long. This is pretty close to the curve, so it didn't actually change the direction that much. This is pulling it a little bit down. This is pulling it to the right. And so you get this, you know, ease around, and it's trying to go toward that point. This point is tugging it up this way. This next point is tugging it more upwards, so you can see it kind of takes a turn after it passes this control point. And then it's starting to taper off. It never quite reaches that because this is lower. So I think that is correct. And let's, just for argument's sake, let's echo max t in here. Get the console up. If anyone remembers what the key combo for that is. You see, so there's 4 segments. There's this original one. There, yeah. So I think that this, I believe that this is correct. I'm not fully convinced. And we need to do 5 there. But we can get more segments, for instance. Let's reload just for argument's sake. You can't really tell because this is already pretty smooth at 10. But we could like pick 15. And that really just comes down to, what you want out of it in terms of precision, like level of detail. Okay. All right, we've got, just about 20 minutes left. So I think that this is a good place to make a commit here. We'll just add everything. Add uniform spline constructors. Okay, really detailed message, yeah. I may have to do it at work, but I don't do conventional commits at home, so I'm sorry if that offends you all. Okay, so I want to finish this up to at least I can make a pre-release. I'm going to change this from, I'm going to make this not 1.0 because it's not 1.0 quality. But you can see yesterday I did a lot, especially on Mat 3, making it work. And I added some things to the README. I want to get this to the point where I can at least push this version, and we can refer to it from Splines, and then we can publish Splines again, and then call that to the end. This inverse for Mat 3 does not spark joy. We're constructing and reshaping a lot of vectors here. It's probably okay. It's good enough. You don't have to do the inverse that often, but it does bug me a bit, just fair warning. So you can see there's a lot of uniformity here, namely that these repeat. That feels nice. These are all the same in each grouping for columns, and then the swapping, which there is probably a better way to frame that, alternates, and that comes down to how you compute the inverse for 3x3 matrices. It's something to do with the negative coefficient on it. Anyway, I was doing that yesterday, making all of this compile, and I have these little swizzles. I say they're swizzles, they're more like compressions. Like, take these components out of Vec3 and giving, Vec2 containing those things. Those might be useful to add to Vec. Just none about if you want, that may be useful. I don't know. Maybe my use cases for this is too niche, and I'm okay with that. It's just a little private function. It's not a big deal. Anyway, okay. We have got. Let's go ahead and make a commit on this. What did I change in Gleam Tummel? Let's look at the diff. Oh, I changed that. Yeah, okay. Let's go This is going to be restore mat3f module. The other thing I did for that, because I was a little bit paranoid about implementing that much math and making a mistake, I did find a mistake while I was implementing it. That mistake was I didn't do the determinant correctly. And there was one place where I got one of the component swizzles incorrect, but I made a little test for it. I was like, hey, this example's from Wolfram Alpha. I know that this is correct. So let's, see if my algorithm meets it, and it was fine. At a later date, I'll make mat4 have inverse as well. It is possible. I just haven't implemented it. And we'll make a test for that. Okay. So I'm going to push that. And let's do Gleam docs build. Open. Let's see what they look like. Bump up the size on that. Okay, so I added some stuff to the README. Oh, and you make it so small again. Boo. Okay, and one of the things that is good or bad about this formulation is that it doesn't use my type aliases, even though I use those in the function signatures. That's okay. That's pretty good. You can see here the one thing I do want to add, because this is inspired by Glam from Rust, not to be confused from the Glam from Gleam, is affine transformation matrices. They are non-square matrices, and that's, they use less space is the main reason to have them. They're less flexible than square matrices, but they use less RAM. So they're often used in cases where you need to do CPU side stuff. I don't think I'll be making aligned vex or anything like that from Glam. It's strictly not necessary, but an affine 2 and an affine 3 might be useful. Okay. That looks good to me. Did I push? Okay. We're going to make a git tag v0.1.0. And I did push the release thing, so it should just push the library when I push that tag. Okay. No compilation errors. The docs look good. Okay, let's push tags. And we'll go back to John Cribs matrix. Well, helps if I type it right. And I don't need to add a secret. I just want to see whether it published. Okay, so it did not. I'm going to have to publish this manually, and that's fine. I am not using, boy, it's really picky. no, that's actually not correct. I am not using semantic versioning. It's actually the same as my sudo password, so it's fine. Okay, so now we've got that. I will 1.0 it when I feel comfortable with it. It's fine. Now we can go back to Splines, and we can say okay. And I'm going to make this 1.0.0, right? And let's Gleam deps download. And I need to make sure that when we go in the showcase, it doesn't use the path for that. Let me look at the manifest. I might have to delete it. Yeah, it's using local source. Okay, so now it should be pulling. Yep, it pulled the one from hex. Yep. Okay. Make sure we can build our showcase again. Gleam run. Okay. And this still works. Okay. I am curious if there's a way to do that confirmation. By the way, this should show up. I'm wondering if there's a way to do that confirmation on Gleam publish without. Let's look at the docs for that. Gleam publish help. It's just -- yes. Yeah. It's okay. So looking at this, so what we did here is we update to the published version of Matrix Gleam. Okay. And I'm going to bump the version here. This is a breaking change, or at least new features, new dependency. Bump to 0.2.0. It's not going to publish on its own, so I'm going to go ahead and Gleam publish. Yes. I am not using semantic versioning. Okay, good deal. I think this is a good place to stop. I'm going to off stream continue working on Matrix, I'm going to finish up that PR I have for Unanaba for the vec library that has the unit vectors, the unit axis vectors. And then we'll come back next week and do some more stuff. I do want to get back to Essentials of Compilation. I feel like I've had enough of a break from it. It's been 3 or 4 months. There's some opportunities to fix some things that we just kind of accreted over time in that project. Specifically, some of the supporting libraries are not great, and I want to fix those up. That's probably not going to be interesting enough to be on stream. I want to get it to the point where we actually can be productive on stream and pick up new material. But I think, yeah, maybe next time we'll do some more splines. And what would be great for our showcase, rather than just plotting them, I would also love to see, like, see a point trace the spline, like have our tick update the time and scale it so that it traces the spline over and over. I think that would be really interesting, and we could do that pretty straightforwardly in our showcase. So would be good stuff. Anyway, see you next week. Thank you for hanging out. You too, Amos. Hope to see you soon in person.